Okay, we're going to talk a little bit about edge cases today. And to do that, let's look at something from back in CSA. Here's a string one problem. And it says here, given a string, if one or both of the first characters is an X, return the string without the X's. Otherwise, return the string unchanged. So in terms of CSA problems, this is a little bit more on the difficult side. And they give you some examples here. And you can see here's Mr. Sarkar's suggested solution. So let's look at this solution and just discuss with your partner for a good 2 minutes about whether this solution will work or not, and we'll talk about it in class. There's only one mistake in it. I'll show you in a minute. Okay, so let me just ask, who wants to take a whack at it? Okay, Mila, I think you had your hand up originally. What do you think is wrong with it, or if anything? That's actually okay, I think. So this will, if it's exactly length 2, this will return an empty string. It won't return a runtime error. It's just return an empty string. There's another problem with it, though. Yeah, Ms. Ben, what do you think? So length 0 is a problem here. Let me show you. So if I run this right now, it all looks happy until you get over here, and then you can see the case you were asking about, I think, was this one, Mila, which is fine. But this one you can see is a problem. And this is often known in computer science as an edge case. An edge case is a slightly out of the ordinary data sample or a run of the program that you weren't expecting. And here the edge case happens to be an empty string. Now, why am I mentioning this? It turns out that to understand how to manipulate a linked list, it's all about worrying about the edge cases. And I'm going to show you an example of that now as we move on to describe the remove method in a linked list and show you, like, have you considered this edge case? Have you considered that edge case? Something like that. And I'm going to just very quickly draw a linked list here for you. So let's try this one here, 7, like this. And let's say the last one points to null here. And let's say that I have a front pointer over here. And let's say that this is my list. Let me make it a little bit bigger so you can see what's going on here. Okay, there's my list. Now, let's say I wrote some code and it's a remove method, and you give it an object and it finds that object, the first occurrence of it, and it removes it from the list, from the linked list. Okay, so for example, let's say that I call this remove method and I gave it a 4. What's going to do here is it's going to go through here and it's going to eliminate the 4. And so after the list, after the function has executed, after the method has finished, the resulting list would then look like this. Okay, and so you write the code, you test it out, you put in the 4, it seems to work, and you move on. The problem is that if you just tested with the number 4 on this linked list, you might not have considered some of the cases which are considered like edge cases. Can you, looking at this first list here, can you see where like 1 or 2 of these might be handled a little bit differently than the others? Okay, 7 is an edge case. Why? I got to change the front pointer. So I've noticed the last 5 years of teaching data structures, like this is exactly the kind of thing that students don't think about when they're writing their remove method for a linked list. They forget that in some occasions you not only have to deal with the item, the node being in the center of the list or somewhere in the middle, but also like a special case if it's the first item over here. What else might be an edge case? Like if the list looks a little different than what it is here, Ben? So we have to make sure that when we test the code, if we give it an element that's not there, that it doesn't like create a runtime error. What should it do instead? What do you think? No, if you ask it to return an index, if you ask it to delete an index, like you say I ask it to return to remove item number 1, this would be item number 1 right here, it's going to return the 9 so that you could use it for another operation. I remember that specifically. I think the other one is probably Boolean. So here, if you ask it to return, if you ask it to delete a 5, for example, you should return a false. You shouldn't crash. See the difference, right? That's an important edge case. What might be another edge case that you might want to consider? Think about the problem that I just showed you a few minutes ago with that that coding bat problem. Yes, sir. 6 might be an edge case. It turns out it probably isn't, but it's certainly worth considering. I agree with that. certainly worth considering. What might be another edge case? Yes, sir. Well, we're not using index here. We're using an object. But if we were doing the other remove method where the index was out of bounds, that would be important. Okay, yes, sir. If the list is empty, that might be another one that we might want to consider. So my point to you is when I ask you to write these methods for your linked list, try to think of all the various edge cases that are possible besides the average ordinary, oh, the thing is sitting right in the center and I'm going to delete it and everything's going to work fine. If you can think of all the edge cases, you're probably going to get it right.